it's this one right here? So what is your role? What is your role as an architect? With emerging technologies changing our field every day, the question of what our role is and what our responsibilities are is changing. Is your job to illustrate the design to convey an image or an intent that is later by other parties then going to be detailed and constructed into the real work? Or is your job to deconstruct your design into a series of pieces of information and dimensions and details that will help others to construct that design in the real world? Or is your job to facilitate the built environment, to mitigate confusion between all parties involved in the construction process, to organize that process and mobilize all parties to work together to create what it is that was your original concept as a designer? Speaking beyond the conjecture and language, what does that mean to us as the industry evolves? Many of us will say, well, our job has always been to facilitate the creations of the built environment. It is true that in an iterative fashion, we have always facilitated a building's creation. We started as designers and we created the look and the feel of what we were after. Then, as architects, we put that back into the drawing form that we sent to other parties. Once the other parties receive our two-dimensional drawings, they were then able to put their own drawings together, adding the information that their discipline needed to ensure the building's integrity. Once these drawings were done, they all had to come back to the original designing party for review. By the time this series of documents reached the general contractor who had put the building together, the amount of drawings had grown. More so because all the people putting these drawings together were working independently. They now had all kinds of information, referring one another back to the original set of drawings. Structural drawings would lead the dimensioning to the architects. Architectural drawings, which had shown structural members, would make sure that the structural information was received off the structural drawings. More time was invested as all of these compilations were put together into one new set of fabrication drawings that were done by either the contractor or the subcontractor responsible for that scope of work. Just like the structural engineer's original drawings, that work now had to go back to both the design parties for review. Only after all parties were done reviewing and agreed everything was ready to be built could construction actually start in the field. But this begs a very important question. If this is the first phase, the first time when review and questions about the building conditions are going on, how much time is there really to react to feedback that comes back from the field? So the architect and the engineer receive feedback from those who have to assemble the building, and they see proposed changes due to constructability, affordability, or simplicity. Can this be built? Is this cost effective? Or is it just too doggone complicated? And now that the construction process is so far gone, is there time to rethink these decisions and in a reactive state where we have just gotten this proposed change, do we have all the information necessary to review these changes and speak intelligently about them? And this late in the process, is it even feasible that we can consider alternatives with the time that we have left? Speaking of emerging technologies that are currently being used by designers and fabricators, can we start to eliminate the consequential process that creates this dilemma? What if the set of deliverables that we produce weren't a set of drawings? Designers in all disciplines now are working in a myriad of software that allows them to manipulate 3D information. Revit, CATIA, Rhino, Grasshopper are all being used by architects and designers, while programs like RAM, RISA, Fast Track are being used in the structural fields. What if it was just understood that these models were going to be the deliverables, and that additional time spent deconstructing these into details so that they could be recompiled into fabrication models just wasn't going to happen? Imagine on a project that the designers came up with the exact form for the structure that they wanted to see in the built environment. They then sent that form to the structural engineer, who much like in the original process, was able to dictate what size member would be needed for structural integrity on that structure. The engineer then could forward that same model to the fabricator, who could take those structural members and say, now that we need certain connections to happen based on both the members and the sizes and the shape, which were dictated by the original designer. In this new process, the deliverable is not actually a series of deconstructed two-dimensional drawings, but rather three-dimensional point data, which is delineating where all of the relevant locations are for everything in this design. Now, it's true that originally the designer created the points, and the points went to the engineer, and the engineer's model went to the fabricator, but in the end of this process, everyone's work is now related to the point data. This means that as the fabricator needs to make minor alterations, or the engineer realizes he needs to resize something, everyone's models are undulating together. What if this actually meant that you had a better deliverable at the end of the project? In this particular example, the original design team, as they deconstructed their design into details, started articulating how it would best be constructed. It was part of the original design that these members could not all be the same size at intersections. It simply was not possible based on the way they thought it was going to be instructed. And this is the lamella that we did at the Arboretum. However, if in the process, such as this rather than recompile the deconstructed drawings that were done by the design team, if the fabricators decided to take what information was important, i.e. the design intent, and then fabricate their own system based on that design, they realized that they could actually come up with a system that appeared more uniform and was, in essence, closer to the design that the designers were looking for originally. They also found out it was faster in the field to assemble, and it allowed a much tighter tolerance at the connection points, and ultimately was cheaper. So, can these processes of emerging technology also help us fight more smartly to keep designs that we sometimes lose due to the questions that get asked late in the game? If we consider the images that we looked at in the beginning of the presentation, we have started to decide on a design intent. Now we will work through the process of detailing and drawing and then submitting for construction, where we begin to receive feedback about the complex nature of the walls. These walls start out as double curved complex surfaces, and they work themselves around until they are completely vertical at the back of the walk-through tunnel. Anyone's been through value engineering exercise knows that sometimes there's a difference between value engineering and reducing the design. And I'm certain that this design could be made cheaper if we simply remove the double curved surfaces and eliminate the walls through the first floor. And it's hard to make a case against that when we go back to our decision making relative to, is there enough time this late in the game to figure out the complexity of the walls? Do we have the information necessary to make those decisions? And how can we fend off the feasibility of the alternative, getting rid of the walls? So what if, the moment we have this design created, we were able to send our panelized skin to a fabrication shop who could then identify the seriousness of the deflection in each of those panels? They could rate those deflections into a series of the costs, and we could start to alter the design little by little to figure out which panels were going to be the most expensive and which were not, thus saving our design. So in closing, we can directly provide the panel fabricator with the same information, so we can produce a better deliverable, better built, by having more intelligent information out of emerging technologies, all coming from our design professionals. Again, this means we have to ask ourselves the question, as emerging technology continues to streamline our processes of design, what is our role going to be in this industry? Was it 10?